everyone, thanks for coming. Today we are going to do a brief review of our week 3 lectures on ODE course. So in this week, we introduce second-order linear ODEs. The second-order linear ODE takes this form. Linear means the left-hand side is linear in y and its derivatives. The coefficients are functions of the self-independent variable t. For the second-order ODEs, we generally need two initial conditions on the value of y as well as the value of y's derivative. There are a special case called the homogeneous equations. In this case, the right-hand side gt equals to 0. For constant coefficients homogeneous equations, they take this form. They have this characteristic equation ar squared plus br plus c equals to 0. So if this characteristic equation possesses two distinct roots, then the solution can always be written in this form. This is the general solution, c1 times e to the power r1t plus c2 times e to the power r2t. However, if r1 equals to r2, then the general solution looks like this, c1 times e to r1t plus c2t times e to r1t, because r1 equals to r2. So this is the case when the coefficients are constant and the right-hand side is 0. For more general case, for general second-order equations, normally we cannot solve them. However, if we have such an initial problem of this non-homogeneous equation, then the problem has exactly one solution if the coefficients are continuous on an open interval containing the initial point t0. On the other hand, if the right-hand side g of t equals to 0, then for this linear equation, if we can find two linearly independent solutions, y1 and y2, then any linear combinations of those two solutions, which we call fundamental solutions, will also solve this homogeneous equation. The underlying reason is that the operator L, the differential operator, is linear, so we can Ly1 plus Ly2 equals to Ly1 plus y2. So we can substitute using any linear combinations of y1 and y2. For non-homogeneous equations, usually we need to make a guess to find a particular solution before we can get the general solution. So how do we make a guess? So for the non-homogeneous solutions, we usually use the method of undetermined coefficients. That is to say, we get the formal solution, but we have an unknown coefficient. Then we put that in to determine if we can find the coefficient that solves the non-homogeneous ODE. If we can, okay, then we find a particular solution. We solve the corresponding homogeneous equation to find the general solution to the non-homogeneous equation. But if we can't, if the guess solution is not correct, we need to replace our guess with a refined one. Thanks for listening.